Hi, and welcome to exercise number 2 of the FM hands-on exercises. In this exercise, we will create a triangular grid and we will connect that to the unstructured grid we made in exercise 1. So this will teach you how to make grids for different parts of your domain and then connect them to each other. So to do that, we start again with Delta Shell that is empty. I have an empty project here, which I will save as exercise number 2. Like so. And again, I will add a DFLFM model and I will re-import my LAN boundary. So under area, I right click on LAN boundaries, import. Okay, I click Scheldt Harbor. So now we have a LAN boundary of not only the river Scheldt, but also the port of Antwerp. And we will concentrate on this little area here on the left bank. So to do that, we will import the grid that we made before. So that will be Scheldt 01. Like so. So this is like the grid that we made in the first exercise. And now what we're going to do is we're going to make a small triangular grid here for the entrance to the so-called Callo sluice, which is here. And we will and we will connect this triangular grid to this curvilinear grid of the river. Okay, so to do that, we open RGF again by double-clicking grid. Like so. So it loads our LAN boundary and our grid that we had previously. So the easiest way to make a triangular grid inside this little area here is to first draw a polygon with the outlines of the LAN boundary. So we're going to do that by doing edit, polygon, edit. And we create a new one. We start here like so. We follow the LAN boundary. So we do this like so. And we keep more or less a distance of one grid cell from the polygon to the existing grid, so we can make the connection later on. And what's also important is that you start your polygon and you end your polygon, so the first 2 points and the 2 last points should be about the grid resolution that you want. That'll be clear in a moment because we're going to refine this polygon. So if I do this and then this, so I have more or less the same resolution here as I have here. So I can refine this polygon to the desired resolution after I glued it again to the LAN boundary, which I'm going to do first. So polygons attached to LAN boundary, tuck, 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 like so. So now the polygon is more or less aligned with what we have as a LAN boundary, and then we can refine it. So we do polygons refine, and we say linear. Then we click first point number 1, so it becomes transparent, and then we click point number 10, and then the entire polygon in between here is going to be started to be refined with this resolution, and it's going to finish with the resolution of this section here. So if these two are the same, then you get a polygon that is refined nicely with the same resolution everywhere. So I click then point number 10, and then you see that I indeed get this nice resolution. Okay, so you see that now because of refinement I lost my connection with my LAN boundary here, and it's also not nicely aligned here anymore. So we can do some editing of that. So we can replace a point here, zoom in a little bit, up like so, and then maybe move this little 8 here like so. So our triangle is more aligned to the, or polygon is more aligned to the land boundary. And once we have that, we first create a new domain, because if we create a grid inside this polygon, we will lose our other grid. It's very important to do domain, new domain first, and only then we are going to grow grid from polygons. So this will allow us to create a triangular grid based on a refined polygon as we have made right now. So I click this, and then you see that I have a nice triangle. So what I have to do now is to make this and this one grid. And you can do that by first deleting the polygon, because in RGF, whenever you have drawn a polygon, then all the operations only happen within that polygon. So you have to get rid of it first. Do it like this. Okay. And then we click multi-select. So this is this button. So we can click multiple grids or multiple domains in one go. So you'll see that this one will turn blue as well, like so. So now both grids are selected, and I can merge them now. So even though they're not spatially connected, they are now one grid. So I can do merge grids. And then again, I save my project. And that's too bad. Let's hope it will save this. I'm gonna manually save this in exercise2, just to make sure. And then I'm gonna close this. Okay, so we managed to rescue our grid. So now we're going to make the connection between the two grids. So again, I go to RGF, and I hope this loads my grid nicely now. It does. Lucky us. And now what we're going to do is we're going to connect this part to this part. Okay, so in order to do that, first we have to make sure that the resolution of this part of the grid, of the river part of the grid, matches the triangle resolution. So we can do that by splitting these cells along the rows. So we can do that by edit irregular grid and then split a row or column. So we start some distance away from this, so we can nicely smooth this out later on. So you can click like so, and then you see that it will make the resolution twice as fine as it was, like so. And maybe around here we can go even a little finer, like so. Now we can firstly smooth this out, and the best way to do that is to go to settings and then orthogonalization irregular. And here you see an orthogonalized versus smoothing factor, and 1 means that everything's going to be orthogonalized, so the angle of the connecting flow link will be 90 degrees with the cell face. Or you can smooth, and smooth is an operation where the surface area of adjacent cells is being made equal as much as possible. So in order to put the focus more on smoothing than on orthogonalizing, we put this somewhat closer to 0, but not too much, because otherwise we lose all orthogonality. And as I've stated before, everything in RGF can be spatially constrained by using polygons. So I can draw a polygon here. First I have to right click, polygon, edit, draw a new polygon. Then I can start here and then nicely delineate the area where I want to smooth my river grid. So that is this, more or less. Let's see that we didn't take anything of the triangles here. No, we didn't, so we're good. Then we can do operations, orthogonalize grid. Then you see that it's already a little smoother. You can do that again, like so. Okay, so we can delete this polygon again. So we can do that by pressing this button and then pressing any of the support points. And then we can focus on this area here. So you now can see that the resolution here matches more closely with what we have in terms of triangles. Okay, so at this point we can save our project just to make sure. And then we make a new domain again, like so, because if we're going to make a little grid here and we actually make it, then we will otherwise we'll lose our grid that exists already. And then there's a neat little trick to actually make a connection grid between these, and that is under polygons. You see polygon between grid boundaries. And how does this work? So you select one of the two grids and then you click on a point where you want the polygon to start. Then you click the endpoint of the boundary that you want to include in this polygon. So this one, and then you see that it'll make polygon points on all the grid nodes. Then you can do the same on the other side. So I can click here, and then I can click, for example, here, like so, and it will do the same thing here. And then potentially I could add another point here. So I can do that by clicking this one and then adding a point here. And we can also replace that so it's more on the land boundary, like so. Okay, and now again we have a polygon where we can grow a grid from, like so. So that gives us our new triangular grid that will make the connection between the two original grid parts. So again, we can delete the polygon and you see that the grid is nicely aligned with the existing grid edges. So if we now do multi-select again, we can select both domains and then we can do operations, grid, merge grids as before. And that will give us one grid. Now what we can do additionally is orthogonalize this, because if we look at the grid properties here, it's probably not very good. You see 0.459. So what we want to do is we want to orthogonalize this part like so. But before doing that, we reset our orthogonalization parameters, because now it's fairly low, so we can put it a little higher first. So you always do this in a number of steps where you increment this value in a number of times. So we do orthogonalize grid, and we are 164. So we can do this again. 130. Now we can augment this to 0.95. Do it again. It's already better. A little more. 72. 67. 66. So we're not making a lot of progress anymore, so we can put it to 99. Like so, 34. Now we're getting where we want to be. 28 and 29. So we're not advancing anymore, so this should be enough. So now we have an orthogonal, not so smooth grid though, especially here, this part, because we put a lot of emphasis on the orthogonality and not so much on the smoothness. But this is now a choice. We could also choose to split this edge again so that it's a little smoother. So we could do a regular grid, split row column, and we could add another grid line here so that the whole thing is smoother and it's still, well, if we do one orthogonalization step more, like so, then it's okay. All right, so that was exercise number 2. So in the next exercise number 3, we will interpolate the bathymetry on this grid. And then in exercise 4, we will actually make a flow model out of this.